Welcome to Apache Karaf Essentials. I'm Jamie Goodyear. This is the second installment in our API Gateway trilogy. This time we're focusing on the Whiteboard Pattern. This is what allows us to talk to the service registry to make a much more dynamic plugin architecture. All of this up next. Let's get into the Whiteboard Pattern, but first let's do a very fast recap of the API Gateway Pattern and the stack we're using. Keep in mind, the whole point of this pattern is to allow all of our clients to talk to a centralized location to take advantage of security, resilience patterns, monitoring, everything being in one location to our backend services and other cloud-based services. Our architecture has Apache CXF providing JAX-RS, that's our RESTful layer. And then below that, we implement standard services that's going to handle, hey, are we just doing a regular proxy or are we going to do composition of multiple carls to give you a single aggregate result? Inside of here is where we will introduce the whiteboard pattern. In our demo code, we present that as an AI knowledge base. It's knowledgeable about all sorts of AIs, be it on-prem, different models, or going out to the cloud. The key piece here is that there is a whiteboard. A whiteboard in the OCI sense is something that allows us to talk to the service registry and let us use the service registry to detect when brand new plugins are introduced to our runtime or their configurations are being updated. We want to reload those plugins with new configs. We use an extra piece of library to allow us to introduce something called a keyed whiteboard, which effectively is just a way of saying, hey, I have a name for a particular plugin, and it's just a quick way for a developer to say, or any user to say, I want to use a particular plugin with my inputs. So in our case, you can have a RESTful service coming in and say, I want to use OpenAI, I want to use something from Ollama, I want to use something on LocalAI, or some kind of a quality of service saying, I want to use the slow lane because this is a piece of work that needs to be summarized, but I just don't need this answer right away. Maybe it's going to be a batch job that wants to have 100 summaries put away on some folder, and we're going to look at them some distant part in the future. And then a fast lane where it's an application that expects us to get immediate feedback. So you want to have that on a pretty beefy machine, or it just expect you're going to be using a lot of tokens and a higher expense account to get that kind of quality of service. Let's dive into the implementation details of this. On the left-hand side of this diagram, what we're trying to explain here is that we have our project API, and then we have a standard implementation underneath it. It's just implementing all of our methods. And that has a connection to our whiteboard. Our case is the keyed whiteboard. We have an SPI interface, and each one of our plugins, be it our demo or ones for Ollama or for LocalAI, they have to implement that. And then we are going to export into the container, say, this plugin implements that interface, and we're going to do it under this particular key name. This is what allows the front end to say, hey, I want to use the local AI with the following prompt, or I want to use Ollama with the following AI prompt. That's the pattern we're going to use to make this work. So let's get into a demo because this gets a lot clearer when we get into the code. What we're going to do in our demo code is show you how we implement a plugin for local AI. The original demo code was just for Ollama, which would be a locally running, and OpenAPI. So in this case, we're going to build one now for local AI and have it be able to load in to our system, be recognized, and start talking to that AI system. So let's dive into the code. Let's start our code review with the original API Gateway project. We're going to look into the Impl module, and we're going to start out at the level of the AI resource Impl. This is the implementation of our CXF JAX-RS front end. Inside of it, we expect in our one call, our generate a response based on a request, take in some application JSON and return some JSON. Under the hood, what we're going to do is take that request, which happens to include the name of a particular plugin. In our case, we will want it to be talking to, say, Ollama or LocalAI, OpenAI, etc., etc. When we get that request ID, the actual plugin ID, we will take that to our knowledge base, which is our whiteboard, and say, get me, based on that keyed value, the implementation that we need to use to be able to talk to that AI. Keep in mind, it could be a particular AI location, a particular model, quality service, etc. Now, we can see in here that this is where we have our knowledge base doing the get plugin, and then it will generate using that plugin based on the given prompt. So that's the input we get from the user. Let's take a look at the whiteboard implementation we're using. It is a very simple one. It just has a get plugin and returns the executor. That is our SPI that we're going to use to say execute our code. Let's take a look at the implementation. We can see that it is going to extend the keyed whiteboard. That is our special extra flavor we're using to say, hey, we want this name associated to an executor. We start with the constructor being passed in a bundle context. The reason we do this is to give the code access to the OCI runtime, and that's where we'll get our hooks into the service registry. And then underneath the hood, we're just going to do the get our service and find if it has a executor by that name. We're going to take a quick look at the SPI module as well, just to show what the executor plugin does. It's just an interface. Each one of our plugins will implement this. Our methods that we're going to use here are just describe, which is going to return a string, just saying which one you are currently using, and then the generate, which takes in a string, we're calling it the prompt, and gives us back our response string. So let's jump over to our whiteboard demo repo where we're going to implement a LocalAI plugin. Now that we've taken a look at where the whiteboard pattern comes into our API gateway, let's look at implementing a plugin for it. We're going to start with our whiteboard demo repository. You'll see that in our show notes down below. And we're going to use this to create a executor plugin that plugs into our whiteboard. And then we're going to integrate that with LangChain4j to be able to talk to our backend AIs. I'd like to give a quick shout out to John Demick, who gave me quite a few hands in making this work nicely with Apache Karaf. So thank you very much. Now let's dive into the plugin. The LocalAI plugin is going to implement our executor plugin SPI. And internally, when we instantiate this plugin, we're going to take two values. One is the model name that we want to use. The second is the base URL. This is going to allow us to point this at various runtime instances of LocalAI. It could be running locally on your own machine, in your server rack, etc. The model name, of course, that's just giving us ability to configure that we want to use, say, ChatGPT, maybe DeepSeek, who knows. This is where we're able to set this up. There's some other areas we could add in variables for in our code, such as temperature, timeouts, etc. For the simplicity of showing you the demo code, we're just going to keep it at the model name and the URL. You're also going to notice we're using the chat language model. This is using part of the LangChain4j library. LangChain4j provides us with a really nice DSL that lets us set up a LocalAI chat model and a builder to be able to set all of our variables up to instantiate our connection and then make that available for us to use. So when we get down to our generate method, we're able to say our model, start a chat with a particular prompt, in our case, just a string we pass in, and we'll get back to responses from that. And that's all being handled by LangChain4j. Very, very cool. In our resources folder, we are using Blueprint for our configuration. Yeah, you could use SCR. I'm using Blueprint just for consistency here between this project and our API gateway. Couple of pieces in here that are important to take a look at. We have a connection to configuration management. We set up a PID to ComSavor Apache Karaf AI Gateway Whiteboard plugin. And we have two values that are set here. One is the LocalAI address and the other the model. In the case of defaults, we set it up to be looking for LocalAI running locally on our machine. This could point to some other location on our network. And we're going to use GPT-4 as our model. Of course, you can change this to something else, and it overrides using that configuration file. We instantiate our plugin, and we pass into it the configuration and get the defaults. And then we publish us into the service. This is where we're getting to that service registry. And we're saying we have a plugin, and its value is LocalAI. Now that will become available in Karaf, our OCI runtime, and say, hey, we have a plugin named LocalAI that you can call upon, and it implements all these methods. So that's the way that we're able to plug this into the runtime and now make it available. So let's go to our console and try this out and get that plugin running in the side. I do want to make one more comment. This is a single repo, so we get the benefits here of having the software development lifecycle only about local AI. Any changes or additions or extra features we want to add can be just for this particular plugin. And that's really good because when we have all of our plugins in a single mono repo, any update you do to one of them, now you're going to be incrementing the versions for all your plugins. If every one of your plugins has their own repo, they can now have independent development life cycles. If you have a bug in one, you can fix that and patch it and update. It just makes it easier for management. And this is one of the key reasons we like using these as a collection of repos. But I digress a bit. Let's jump onto the terminal and take a look at the runtime code example. Let's start by taking a look at what's in our terminal. On our first tab, we have a running instance of Apache Karaf. This one is currently running OpenJDK 17 from Azul. We have already installed the full API gateway. We have the existing plugins, so that's just the one that can talk to Ollama instances or OpenAI. That is pre-existing here. We have not yet installed our LocalAI oriented plugin. If we were to talk to our LocalAI version 1, I would fully expect it to fail for it's not being installed. Let's just take a quick look at the Ollama, which we can see is currently working. Let's go ahead and build out our repo, and then we'll have that available for us. So let's go remote -v. We can see our Git repository, all of our project code. We're going to do a quick build. This will just take a few seconds for it to complete. And now we have the bundle available in our M2 repository. As a side note, on our last terminal here, we have the etc folder for Apache Karaf. Inside of here, we have a configuration file for our plugin. You'll see that we're going to have LocalAI use the model for GPT-4, and we are going to be using the locally hosted version of LocalAI. Let's go back to Karaf. So we want to do an install and immediately start our brand new bundle. So we're going to go com/savoir/whiteboard-demo. This is going to pick up and start that new plugin. So when we do our list, we're going to see that we have the Whiteboard demo plugin is now available. When we go back to our command to talk to LocalAI now, we expect it to talk to the LocalAI. And we can validate that by taking a look at the running logs of our LocalAI. We currently have that in Docker, and see that it's been reaching out and talking to it. So it's kind of cool. We now have the ability to start, how is your day? We are fully talking now to LocalAI, and we can switch over talking to Llama, which is hosted on Ollama. And this is the whole point of this API gateway. We now can write in plugins for all the various backends we want to talk to, be it on premises or out in the cloud, and just keep adding capabilities. It's pretty cool. With our demo complete, I want to draw your attention to our original video on the API gateway and the reasons why we use them in enterprise architecture, and to our upcoming video that we're going to be releasing on how to create your own custom Karaf commands. So that AI ask command we're using, we're going to show you how you build them and the way that they work. A lot of people like to use them on their own services as a quick way to interact instead of having to set up front-end clients and go the whole way through. It's kind of neat, and it's a great time saver. I also want to draw a little bit of attention to our playlist on the Apache Karaf Essentials. It's loaded with tutorials and information on how Karaf works, OSGI. Anyone who's interested in that, I strongly recommend you have a look through all those videos. Now we're at that time again where I have to say, please like and subscribe to our videos and comment on down below. We really appreciate hearing from you, and thank you for watching this one. Have a great day. Cheers.